Today we're going to discuss the OSI model and segmentation, and then we're going to conclude with reasons for segmentation. And with that, let's go ahead and begin this session. We will begin by talking about the OSI model and segmentation. So what is segmentation? Well, it's taking a single network or system and breaking it into smaller discrete units. This can be achieved physically or logically. There are many reasons why you might want to segment a network. Some of them could include to ease administrative tasks, to achieve performance gains, to increase security, or to comply with regulations. As I mentioned earlier, segmenting a network can be achieved physically or logically. And either way, it involves different levels of the OSI reference model. It can be achieved at layer 1, the physical layer. This is taking a single network and making it into more than one network through the use of cable runs and equipment. This is the most extreme example of network segmentation. Not only is this the most extreme example of segmentation, but it's also an example of physically segmenting a network. You can also segment a network logically at the data link layer, which is layer 2, or at the network layer, which is layer 3 of the OSI model. This is taking a single network and making it into more than one by logically dividing the network. The logical segmentation of a network takes the least amount of physical resources to achieve it. Now let's move on to reasons for segmentation. First up is compliance. Some rules and regulations require that certain data be kept separate and secure, as in the Payment Card Industry Data Security Standard, or PCI DSS. This requires that you keep customer information separate and secure from normal business information. Segmentation allows for the regulated data to flow across its own network, keeping it more secure. Another reason for segmentation would be for network performance optimization. As a network increases in size, the amount of data that flows through them usually increases. This can slow down the performance of the network. Segmentation breaks the larger network into smaller units, which can lead to an increase in performance on those segments. Related to network performance optimization is the creating of high-performance networks. Some applications require more bandwidth in order to perform at the desired higher level. Voice over IP, video teleconferencing, and media nets, which are all examples of streaming services, all perform better when they are on their own network segments. A major reason for network segmentation is to separate private from public networks. Organizations often allow the public to access the internet from their locations. These are places that offer free Wi-Fi. Segmentation allows this traffic to be kept separate from the private corporate traffic. Then there are legacy systems. Some organizations use systems that are considered critical to their operation, but are not capable of residing on modern networks. Segmentation allows the legacy system to reside on its own subnet and network without compromising its performance or the performance of the rest of the network. Then there are testing labs. The lab can be used to test new applications, operating systems, update patches, so on and so forth. If these tests occur on the main network, it is possible that this testing could inject a problem into the main system. Segmentation allows for the testing to occur in a secure, easily controllable environment. And finally, there's security. One of the main reasons for performing network segmentation is for security purposes. Segmentation allows network and systems administrators to more easily control the flow of data between systems. Segmentation also allows network and systems administrators to more easily control access to network resources, therefore creating more security. An example of segmentation for security would be honey nets. These are network segments that are created with the sole purpose of attracting any network attacks through the use of multiple honey pots. Honeypots are systems that are configured to be attractive to network attackers, helping to draw attackers away from the main network systems and into the honeynet. The network segment of honeypots allows the main network to remain secure and gives network administrators an opportunity to study an attack, including the methods of entry, so that countermeasures can be developed to prevent future breaches. A system that should be segmented are SCADA systems, or Supervisory Control and Data Acquisition Systems. These are the most widespread of industrial control systems, or ICS. The industrial control system uses coded signals over communication channels to provide control of remote equipment. They're commonly used in industrial applications to monitor and control systems. Utilities often use SCADA systems to control their operations through the use of DCS networks. That is a distributed control system network. The DCS allows for the control of multiple SCADA systems from a single location. The StutNet virus was originally designed to attack SCADA systems and can spread through the DCS, leading to more damage from the virus. Segmentation of the distributed control system can limit the amount of damage caused by such a virus attack on industrial processes. Now that concludes this session on the importance of network segmentation. We talked about the OSI model and segmentation, and then I concluded with reasons for network segmentation.